This will be video 2 of the second part of homework 7, looking at section 4.5. So in your homework you should have a problem similar to this, where we're integrating a trig function. Okay, now these are different from previous ones that we've integrated with trig, because remember, in all of the rules, okay, that we have learned, those basic integration and derivative rules, it was sine of x, sine of z, sine of t, sine of u, whatever. Okay, it was just that single variable. And even when we're taking derivatives, if it said the sine of something other than x, remember we had to do something special. Same thing here. In integrating, if it's not the sine of x, then we're going to have to do some u substitution. Okay, so we're going to determine what our u needs to be. Usually it's inside of something. So when I look at my problem, 2z minus 7 is inside of those parentheses. I'm going to let that be my u. Okay, there is a way you can check to see if you've chosen the correct u, and that is when you take its derivative. Okay, you should see the derivative somewhere inside the problem. Okay, and we don't care about numbers, just really about letters. Okay, so if I take the derivative and I get just a number, that doesn't matter if it's anywhere in the problem, because the number we can pull outside. What's going to matter is if that letter is there, and if a letter that's in my derivative is not in my original problem, there's more work we need to do. Okay, none of our problems that I'm going to give you are going to require that additional work. Okay, so when you take the derivative here, it's either going to be a number, which doesn't matter if it's in the problem or not, or the derivative that you get will be somewhere in the problem and therefore it will cancel out. Okay, so when I take the derivative of u, I get 2, and don't forget to include the dz. Okay, so I'm going to come over here, I'm going to substitute. I'm going to say the sine of u. Alright, because I'm using the letter u, I don't want to put dz. I need something to substitute in dz's place that also contains the letter u. So I'm going to take du and I'm going to solve it for dz. So dz, to get it by itself, I would divide by 2 on both sides, so that would give me du over 2. And I'm going to put that in dz's place. So this will be du over 2. Now notice I have everything is in terms of a u. This 2 that's in the bottom here, remember it's a denominator and there's an understood 1 on top, so I'm going to take that 1/2. I'm going to bring it out front. That comes from here, 1/2, bring it out front. And now we have the sine of u du. That's a single variable. It's in my chart. So when I integrate sine, the integration of sine is negative cosine u du. Okay? Sorry, no du. Once I integrate it, it becomes plus c. Alright, so now what I have is negative 1/2 cosine u plus c, if I'm simplifying. Now remember, our original problem started in terms of z, so I got to come back in here, and what u was representing, this 2z minus 7, I got to put it back in there. So whatever variable I started with, that's the one I have to end with. So in place of u, we put back 2z minus 7 plus c. And you can leave it like this, okay, or you could write it like this. Negative cosine of 2z minus 7 all over 2 plus c. So either this way or this way, alright, is sufficient, okay? Alright, moving forward. Alright, the next one. Alright, also, if you'll notice when you're looking at the homework, before I move forward, when you're looking at the homework, okay, notice that it says use integers or fractions for any numbers in the expression. Okay, so no decimals, and then use fractional exponents. Okay, so if you start out with the square root or something, it wants you to write the answer using a fractional exponent. Don't take it back to square roots or cube roots or whatever. Okay, so square root would be 1/2 so on and so forth. Okay. All right. The next problem we want to look at looks like this. So I want to integrate x cubed times the square root of 81 plus x to the 4th dx. Now, we don't have a rule that handles square roots, so we would have to rewrite it, and we don't have a rule that handles products. Okay, so we're going to have to do something different, and we're going to use the substitution method. Okay, so let me write this problem down. Alright, so this will be the integration of x cubed times the square root of 81 plus x to the 4th dx. Alright, remember, our rules do not contain any square roots, so I'm going to rewrite this as the integration of x cubed times 81 plus x to the 4th to the 1/2 power dx. Okay, now because our basic rules that we have for this class, okay, do not contain anything related to a product, we got to do a little bit of substitution. That's our next thing that we know to use. Okay, so I'm going to come right here, I'm going to pick something to be u. Remember, u is usually inside of something. So the 81 plus x to the 4th is going to be my u. Okay, now I want to take its derivative. I need something to go in place of this dx so that everything will be written in terms of the same variable. And so the derivative of 81 plus x to the 4th will be 4x cubed dx. Alright, now I'm going to come over here, I'm going to rewrite with my substitution. So I have x cubed in place of 81 plus x to the 4th. That's what I'm letting u be. It's raised to the 1/2 power. Alright, and then I have dx, so I'm going to solve this for dx, dividing both sides by 4x cubed. So that'll be du over 4x cubed. Okay, now this one is slightly different from the other two that we worked, in that there's no longer just a number in there. There's no longer just a number in our derivative. Notice there is a variable. And so here's what I was talking about earlier. Alright, it doesn't matter if it's just a number. Okay, we're going to pull that number out to the front anyway, but what matters is that letter. And if I don't have something in the problem that this x cubed will cancel out with, I got to do more work to find some way to get it all written in terms of the same variable. Okay, so when you take the derivative, okay, to know a way to check to see that you've chosen the correct u, when you take the derivative, okay, and you have something more than just a number, all right, meaning there's a variable involved, I'm looking to see, is this x cubed, my derivative, is it somewhere in my problem? And yes, it is. Okay, so I know I've chosen the correct u. And what's going to happen is I'm going to rewrite this problem so maybe we can see what's going to happen. Alright, remember this is the same thing as this, and you don't have to do all this work if you can see what's happening. Okay, all of this is being multiplied together, so really it looks like this. X cubed times u to the 1/2 times 1 is just that. And then on the bottom we have 4x cubed times du. And notice that this x cubed and this x cubed will divide each other out. Okay, so like I said, you don't have to rewrite all this. I just want to show you this is in the denominator and this is in the numerator. All of this is being multiplied together. And so this x cubed and this x cubed will divide each other out. And here's what we're left with. That 4 is still on the bottom and a 1 is still on the top. So I can pull that 1/4 out. Alright, and I'll be left with u to the 1/2 du. Okay, now this is a single variable raised to a power. I can integrate that. So that'll be 1/4 times, and I'm going to integrate that. 1/2 plus another 1 would give me 3/2, dividing by the 3/2 plus c. Then when I simplify it, That'll be 1/4 times 2/3, just taking the 3/2 and flipping it over and multiplying, times u to the 3/2 plus c. Alright, 1/4 times 2/3 would give me 2/12, which simplifies to 1/6 u to the 3/2 plus c. I don't want it left in terms of u. I started my problem with x's, so I got to go back and what u was representing, put it back in. So that'll be 1/6 times u is representing 81 plus x to the 4th, so I'm going to put that back in there. All to the 3/2 power plus c.